Translations of functions. What we did in the last section, we talked about general transformations of functions. Now, what we didn't talk about was why does, if we have something added to x, is it moving it to the left 3? It doesn't kind of make sense. Seems like if we're adding something to x, it should be moving to the right 3. We're taking all the x values and adding 3 to it. Well, let's go ahead and take a look at what's happening, because whenever we're adding that 3, it might be adding to the x value, but it's generating our y value. So that's the thing that's changing. So let's take a look. So the parent function right here that was given, f of x equals the absolute value of x, would actually look like this. It'd be at 0, 0, and it'd be going up like this, and then it would have another one going that way. You can see that it's been shifted to the left 3. That point of origin where both of those lines are coming from has been moved to the left 3, but it says plus 3. Why is that? Well, let's go ahead and take a look at an XY table and talk about where 0, 0, or if we, on our parent function 0, if we had an x value of 0, where would our y value end up being? So let's use that new equation. Say we had 0 plus 3. I'm using the g of x right now to see why it's shifting over 3. Y equals 3. So you can see that's where that point came from. You're sitting there going, well, that doesn't make sense. Well, let's go ahead and take a look at it shifting even more left. So about -3. X is going to be our -3. So y equals the absolute value of -3 plus 3, which is going to be y equals the absolute value of 0, or y just equals 0. That's where we're going to end up getting our new point of -3, 0. So whenever we're doing this plus 3, it has to do with how the x values are being manipulated to create a y value. That's why whenever we're going to go about doing this, we're looking at plus 3 being a shift to the left 3 instead of to the right 3. Now here you can see on the quadratic, just a simple parent function, x squared, that we have -1. We already went over why that's going to happen, because whenever we're substituting x values in, it's going to be manipulated to create that y value. That's what the transformation's doing. So this little shift right here is ultimately going to have the result of moving everything over right 1. That's why I just started the parent function at +1. I just moved it from 0, 0 to 1, 0. So let's take a look at some examples and see what's going on. You're going to see that the transformation rules from the previous section hold true to this, even though they're not linear functions. These are all types of functions. So whenever we're doing this, you're going to see the shifts taking place. All we have to do is be able to graph those types of functions, and then we can start using the transformation rules. So I'm going to use yellow. We can see that that is +1 right there. We know that +1 means it's going to be shifting left 1, not right 1. So I took the parent function x squared and shifted it over 1. You can go about doing this by using just your standard method of graphing a quadratic, and you're going to see that everything shifts over 1. You can also just take the standard quadratic and plot it where it would be, which would be like right here, and then it's going to go up like that, and then just shift it over to the left 1. Regardless of how you do it, substitution is always a surefire method of generating the appropriate coordinates. So I would substitute x values in, generate your y values, and then continue to do that and then graph the points accurately. Here you can see that outside of the absolute value, we have a -1. Nothing is happening to x. That means we're talking about a y manipulation. So that down 1, you can see that the point that should be at 0, 0 has now been shifted downward 1. Here we have the standard parent function of the absolute value of x. You can see that something's happening with x inside of the absolute value bars. So that means that a -6 is going to be shifting it right 6. And the same thing's going to hold true for the example we went over as to why it's shifting right 6. Everything that's being manipulated for x is going to be affecting the y. So those y values are looking like they should be in a different location, which is why they are appearing in a different location, shifted 6 to the right. Here you can see the standard quadratic. Nothing's happening to x, otherwise it would be in parentheses like this first one. So it's outside of x. That means we're talking about vertical movement. That's going to change where the starting point is, where our 0, 0 point should be in the parent function, and it's going to be moving it up 3. Here you can see we have two transformations or translations taking place, a vertical and horizontal. X is going to be moving to the left 3 and then down 5. You can see that's exactly what happened. 1, 2, 3, 1, 2, 3, 4, 5. Here you can see the x is being subtracted by 8, and outside of that is going to be a vertical shift of down 6. You can verify that by going right 8, 1, 2, 3, 4, 5, 6, 7, 8, and then down 6, 1, 2, 3, 4, 5, 6. Again, knowing how to graph absolute value equations and learning how to graph quadratic equations and those types of functions is definitely a critical part to understanding how to start doing translations with them as well. So we got -3 right there. That's going to be to the right 3 and then up 2. You can see that's exactly what I had. 1, 2, 3, and then 1, 2. Here you can see it's moving to the right 1 and down 8. You can see that's exactly what happened. Right 1, 1, 2, 3, 4, 5, 6, 7, 8. With all these things holding true, this is going to continue to happen. So here we can see that we have a parent function given, and then we are going to be asked to write the equation for what it was translated to. So reverse of what we were just looking at. So let's take a look at it. If we know that this point right here was supposed to be at 0, 0, and now it's been shifted to the left 4 units, we know that we're talking about the absolute value of x plus 4. That plus 4 is going to move it to the left 4 units, and we went over that first example as to why that's happening. You see this quadratic here. Well, it's the parent function. We can see that the point of 0, 0 has not moved. So all that has happened was it flipped. Anytime we want to flip it, we're going to take the opposite of the function. So a positive x would go upward, a negative x would go downward. You can see that the 0, 0 point of the parent function, absolute value of x, has been shifted. It went over 1, 2, and then up 1, 2, 3, 4. So that means x plus 2, and it went up 4. 1, 2, 3, 4, plus 4. But it's also the negative because it's been flipped upside down. So you can see that the 0, 0 point, where it would typically be starting in the parent function for the quadratic x squared, has been moved. How far moved? 1, 2, 3, 4, 5. So x minus 5, and then 1, 2, 3, up 3. So plus 3. It's still facing upward, so it's not going to be negative. Here you can see the parent function where this should be at 0, 0 has been shifted downward 1, 2, 3, 4, 5, 6. So that would be x squared minus 6. It's not happening to the x value, it's a vertical shift, so it's going to be outside. When I'm talking about outside, here's what inside looks like, here's what outside looks like. Absolute value of x is going to be where that should be at 0, 0, but it's not. And it's been flipped, so we're going to go negative absolute value. So over 1, 2, 3, 4, 5, 6, x minus 6, because we went to the right 6, and then 1, 2, 3, 4, 5, 6, plus 6. You can see this 0, 0 point has been shifted. We don't know, so let's count. 1, 2, 3, 4, and then 1, 2, 3, 4. So it's still facing upwards, so we're going to have x plus 4 since we're moving to the left, and then it went down 4, so minus 4. Here you can see this point in the parent function should be at 0, 0. It's facing upwards, so it's still positive. That means we have a shift of 1, 2, so x plus 2. And then we have a vertical shift of 1, 2, 3, 4, 5, 6, 7, plus 7. These are the basics behind how these transformation rules are being applied.